All right, this is going to be a brief lesson about understanding fractional exponents. You might notice I wrote that as my topic up at the top. And what does a fractional exponent represent is my essential question. I'll say that one more time. What does a fractional exponent represent? And so we're going to start with what is the pattern. You can pause the video at any point to catch up with what I'm writing. So what is the pattern is what we're going to start with. I'm going to start with this, the square root of 16. Hopefully you guys would tell me the square root of 16 is 4, and it's because 4 times 4 equals 16. And so when you take the square root of something, it finds the number that multiplied by itself gives you the number under the square root. Something similar can be said if I take the cube root of 27. That's going to be equal to 3 because 3 times 3 times 3 equals 27. And so the cubed root of 27 is 3 because it found a number that when you multiply it by itself 3 times, you get 27. Something similar happens when you do, say, the, let's say the 8th root of, let me just find something that actually works out here real quick. The 8th root of 256 is 2 because, I'm going to write this with a shortcut here, 2 to the 8th power is 2. And so one way of thinking about this is that whenever you take a root of something, whether it's the square root, which usually doesn't have a number written next to it, or the cubed root, or the 8th root, or the 75th root, you're finding the number that when you raise it to that power, you get the thing back. And so, sorry, this should be 256. All right, so that's the foundational knowledge. Here's the pattern that we need to look at. If I take the square root of x, it turns out that that is x to the 1/2. And you might wonder, why do we have to have a fractional exponent? Mathematicians love this kind of thing. They say, well, I totally know what x squared is. That's x times x, because it's 2 x's. But if we have x squared, why can't we have x to the 1/2? And we have to try to explore what that is. And so right now, it's a pattern. I'm going to look at the cube root, cube root of x is equal to x to the 1/3. And the 7th root of, x is equal to, you guessed it, x to the 1/7. I'll extend the pattern a little bit. If I have x squared underneath and I'm taking the cube root of it, that becomes x squared to the 1/3. And you'll remember that when you have power of powers, or parentheses, you simplify by multiplying, so that's 2 times a third, which gives me x to the 2/3. And so hopefully the pattern you're noticing is that whatever the root is, that becomes the denominator of the fraction on the root. And of course this one is blank, but it's actually an implied 2. And so that's the pattern. The radical's root number becomes the bottom of the fraction when you're thinking about the exponent. And so the question is, that we can naturally ask after that is, why is that pattern so? And I'll give you a brief proof here. So if I take the square root of 16, that gives me 4. So that means that if I take the square root of 16 and square it, it's going to be the same as taking 4 and squaring it, because the square root of 16 and 4 are the same. And 4 squared is 16. And so I'm going to write square rooting, square roots and squaring undo each other. They are opposites, like addition and subtraction. And so the same thing's going to be true of taking the cube root of x and raising it to the 3rd power. They're just going to undo each other, and so I'll get x back. All right, so that's the first part of what I want to talk about. What if I take 16 to the 1/2 power, and then I square that? And so if I remember my power of powers rule, that means I'm going to multiply. So that's going to be 16. 2 times 1/2 is 2 halves. 2 halves is equal to 1, so that's 16 to the first power, but that is just 16. So take a look at this. This is kind of weird, but I have this half power thing here, and I raised it to second power, and I got my base, which is 16, back, which means that 1 half power and squaring undo each other. Therefore, because I have these two sentences that make sense, I have that square roots and squaring undo each other, and I'll highlight that part in red. And I have that half power and squaring undo each other. That means square roots and the half power must be the same. And so I can conclude that the square root of 16 is equal to 16 to the 1 half, which means that they're both equal to 4. And so that's kind of why it works. Like if you just pound out the math using exponent rules, you find that the square root and a fractional power do the exact same thing. When you're working on the problems, however, all you're going to do is try to focus on this pattern. And so if I look at this problem here, it's most like this problem because I have a number that's underneath the radical and I have a cube on the outside, or sorry, a third root on the outside. And so this is going to become 5 squared times a third, which should come out as the fraction 5 to the 2/3. So the thing that's on top, whoops, sorry, the thing that's on top of the radical, the cube, that 3 is going to become the bottom of the fraction, and the square underneath the radical becomes the top of the fraction. And hooray, I got it right. So at this point, you're going to want to take a couple minutes and write a summary. Really focus on that so that you have a good sense of why this happens and what pattern that you need to look for. Because when you do that summary, you're laying down memories that help you with the